Dear students, welcome in video number 15 of NSEP 2022, and in this video we will solve a problem and in which we determine the electric field inside and outside of the sphere. And the problem is a sphere of radius r is charged with volume charge density rho such that rho is directly proportional to small r. R is the distance from the center. Variation of the electric field with small r for all values of r less than equal to capital R and r greater than capital R is best represented by, we have these four options A, B, C and D. And as per problem, this is a sphere, this is center, radius of this sphere is capital R, and this is a point P, and this distance is small r. And suppose total charge B Q, then electric field at an outside point P such that, we are taking the case such that small r is greater than capital R. This small r is greater than radius of the sphere. And in this case, the electric field at point P becomes E is equal to 1 upon 4 pi epsilon naught into Q upon R square. And we can say that 4 pi epsilon naught and Q are constant. So we can say electric field is inversely proportional to R square. Now we can take the case when small r is less than capital R. Suppose this is a sphere, this is a sphere, diameter, center, and this is point P, and this is small r. Now, and this is capital R. Now small r is less than capital R. In this case, we can apply the suppose we can imagine a sphere of radius small r. This dot sphere, this dot circle represents the sphere of radius small r, and now we can apply here Gauss law. And as per Gauss law, E dot ds equal to 1 upon epsilon naught times of Q. Rho is charge density, and suppose dq is the charge on the this imaginary surface, then dq becomes rho charge density into volume 4 pi r square into, if dr is the thickness, q becomes integration of dq. So we can write here 1 upon epsilon naught integration rho 4 pi r square into dr, and we can take limit in right side 0 to r, and this is close integration, and it becomes E dot ds equal to 1 upon epsilon naught 0 to r rho 4 pi r square dr. And in question it is given that rho is directly proportional to r. So if rho is directly proportional to r, rho is directly proportional to r, or we can write rho equal to k is a constant, k into r. So surface integration E dot ds equal to 1 upon epsilon naught integration 0 to r. This row is k into r 4 pi r square dr, and it becomes E electric field constant integration of ds 1 upon epsilon naught k 4 pi integration 0 to r cube dr. Integration of ds, it represents the surface area 4 pi r square, and it should be equal to 4 pi k upon epsilon naught integration of r cube is r to the power 4 upon 4, and here 4 pi is cancel out and it becomes E equal to k upon epsilon naught 4 epsilon naught, this is 4, r to the power 4 upon r square, or we can say k upon 4 epsilon naught r square, it becomes square. K upon 4 epsilon naught are constant, so we can say E electric field is directly proportional to r square. So inside the sphere, electric field is directly proportional to r square, and outside the sphere, inside the sphere, electric field is directly proportional to r square, and outside the sphere, electric field is inversely proportional to r square, which we have already obtained. So if we see the representation in A, B, C, D, in D, this represents the electric field is this is inside the sphere, it represents the electric field is directly proportional to r square, and this curve represents the electric field is inversely proportional to r square. So option D should be right. So dear students, we will meet again in our next video number 16, and keep in touch. Thank you very much. And dear students, Asian Physics Olympiad Cell has already started a WhatsApp group for you all, and all these type of videos will be available on that group. You can join on the group without any charge.